Good day, everyone, and welcome to today's webinar on XRF analysis and loss and ignition by TGA. We're excited to have you all join us as we explore two essential techniques used across a wide range of industries, from material science and mining to cement production. Our session today will provide an overview of how LOI is important in X-ray fluorescence spectrometer analysis and how LOI measured by TGA gives insight into compositional and thermal properties of materials. Joining me today is my colleague Frederick, who will share his expertise and practical insights, particularly on the integration of these techniques and what the data can tell us. Whether you're new to these methods or looking to refine your understanding, we hope this session provides valuable takeaways. Please use the Q&A tab to ask any questions, which we will then also at the end of the presentation gladly answer some of the questions. And yeah, over to you, Frederick.
Yes, thank you, Jackie. And so welcome everybody to this webinar. So like explained, today we will speak about loss of ignition and the importance in XRF analysis. So first, let me introduce the company XRF Scientific. So XRF Scientific is an Australian company based in Perth. So we started in the year 1972 with the production of flux, and we continue the story with the production of gas, platinum labware, electrical fusion machines, weighing machines, and more recently by the acquisition of the company Orbis, crusher grinders. We launched it in 2022 our first TGA analyzer, and we started carbon sulfur analyzer and other technique by the acquisition of LabFit in 2024. So we are worldwide based, and the production sites are based in Melbourne and Perth. So let's start the presentation, and so the loss of ignition in the XRF analysis. So why we do consider LOI in fusion bead XRF analysis? So in the fusion beads, the determination of loss on ignition complements the elemental analysis of the elements and or the oxide concentration. To obtain 100% of the sample, we need to do the XRF and the loss of ignition. So to obtain the accurate determination of the loss of ignition is really important in many industry and application. So like iron ore, bauxite, cement, limestone, industrial minerals, and of course many others. So it's really important that the LOI need to be determined with accuracy and precision, and we can not use an average or a usual LOI. It's not good enough, and surely for quality control. And also the LOI, and surely when it's made at different temperature, give value insight into the mineralogy composition of the sample. So for the fusion beads, there is two ways to start with the sample, or we start with a calcined sample and we add the flux. And then in that case, the LOI is determined separately in advance or on the site, or we start with the uncalcinated sample. And in that case, the LOI is known in advance, and we will do a correction factor because we start with the as received sample, and we want to do it as ignited, and there is of course a deletion factor. Or the LOI is not known, and this is another option. The spectrometer will report the calculated LOI, but this way of calculation requires that the sum of the concentration is correct for all the elements, and that's not often the case, and surely if you don't know all the elements present in the sample. So now how it's determined and calculated on the manual way. So the loss of ignition is made with a dried sample. We take 1 or 2 grams, And we set the temperature depending of the norms or of the application at temperature like 950 up to 1050 degrees at plus minus 25 degree in a muffle furnace. And this process is relatively, I will say, long because there is a lot of steps. So first we need to do a thermal cleaning of the crucibles in the furnace, and then after we need to cool and desiccator, and then after weight the crucible, record the mass, and then transfer the sample in the crucible and again record the mass. And and then after transfer as fast as possible the crucible inside the furnace for the LOI determination during an hour and a half, 2 hours, depending of the product. And then after we remove it again, and then we put in the desiccator for the cooling to avoid the samples is catching moisture, of course. And then after we will again reweight the crucible and record the final mass. So we can see that this process is relatively long and could last more than 3 hours and a half, and even more time in some cases. When we use the manual method, we of course need to be sure that we reach the constant mass. So when we speak about constant mass, means that the change in weight is below 0.05%. So it means 0.5 milligram in a sample of 1 gram. But when you use a manual process, of course, you are never sure that you reach constant mass. And if you make the test of a sample, of course, it's really time consuming because you need always to cool in a desiccator. So in practice, we use a fixed time, and of course, we hope that we reach the constancy for all the samples. So the calculation of the LOI is quite simple, and it's made by this equation. And of course, the manual process, so like described it, is multi-step, so time-consuming, and of course, operator dependent. And it starts to be tricky, complicated if you have multi-heating step to do. So most of the time, you need to have many furnaces to do that separately. So this is the reason why to use a thermogravimetric analyzer, which allow to have a precise control of many parameters like the temperature ramp rates, the all times, the atmosphere. So this process is automated, and it's possible, of course, to monitor the weight change during the whole process and check the various loss of weight during the whole eating. So the TGA here, in this case, it's a macro TGA, so not a micro TGA. So macro TGA means that we are working with gram size sample. So the big advantage is that we have better homogeneity, so more quantity, a larger sample, and it's perfectly perfectly made for cross-compositional analysis like hash, LOI, volatiles, moisture. And this technique provide, of course, high precision measurements. So the specific advantage of the automated thermogravimetric analyzer. So we, of course, improve the workflow efficiency. So replace the slow, labor-intensive gravimetric technique. We don't need to do the thermal cleaning of the crucibles. We no need to wait the samples at room temperature after each step. And that's because we have a reference crucible inside that deduct the weight variation we can have from the crucible. So no need to do a thermal cleaning, and no need to reweight the sample at room temperature. So we can see that during the process, you have a small gain in weight, a relative gain in weight for the reference crucible. And so that's the reason also we don't need to use a desiccator. So it's a process is fully automatic. So from the sample loading to result analysis and report generation, we can do sequential analysis without operator input. So we can see in the thermograph on the right. So here we have the temperature in sequential increase, and the weight lost of the different sample in percent. And of course, what is very valuable if we have an automated endpoint recognizing, and most of the time we use the mass constancy, but for some norms, we use a fixed time, and we can even use combination of both or other termination parameter. So the key features of our TGA, so the XR TGA 1100. So again, it's for analyzing moisture, volatiles, ash, fixed carbon, loss of ignition in a variety of organic, inorganic, and synthetical materials. We have 30 position for the samples plus one reference, so it's made for high throughput. We can reach 1100 degree, and it's an advantage because we can reach some knobs who require higher temperature, but also it's interesting because we reach the fusion temperature, and in some industry, they prefer to do the loss at the fusion temperature for accuracy reason. So it's fully, of course, automated process with a fast heating and a fast cooling. And as you can understand, the cooling is really important for such machine. Surely, if you want to do many cycles during the day, we need to be able to quickly come back at the room temperature to be able to restart a cycle, a second cycle, or a third cycle during the day. And of course, you have a fully integrated computer to deal with all the data. So just a quick description of the machine. So we have two furnaces, top and bottom furnace, to have a perfect heated environment for the crucible. We have, of course, a temperature control via thermocouple. We have an analytical balance, so it's a four-place precision balance, and the balance is placed in a thermostable environment, and the balance is linked with the crucible inside the furnace via a pedestal. And of course, we have the computer inside with a touchscreen to control the system. So we have also the carousel with the 31 position, where the touchscreen, you can tilt the touchscreen to have a better view when you are loading the crucible. We have an extraction system. Surely, when we are doing a product, we are producing vapor fume. And also you can integrate different gas environment. So you have an integrated gas switching system, depending if you want to work in air or in a NINET environment like nitrogen, or in an oxidated environment adding oxygen. So you can add up to 3 different gases inside the machine. Okay. So of course you can set the programmation, set the parameters of working, so the different profile of temperature, also the way you want to stop the process by constant mass and time, so the minimum time, the number of weighing, so you can set all the parameters for the programmation, and of course it's completely norm compliance to be able to work directly after installation. So the way to working is relatively simple. So you will first select the appropriate program. Then after you will define with how many sample you want to work. So you can work with the 30, but you can also just work with 10 or whatever. Then after you will put the crucible, the machine will weight the crucibles first, and then after we will load the samples after identification. And when all the samples are, of course, loaded, we can start the measurement. And at the end of the cycle, we will retrieve the results that can be also transferred to elsewhere. And of course, we have a program after to deal with all the results. Of course, the main important, in main case for XRF are the loss in percentage, the loss at the final temperature. But in some case, it's interesting to check the curves and see where we have a loss for I will say, more qualitative analysis. And really important, it's linked LIME's compliance, meaning that the data can be transferred directly to a dedicated location. And of course, no need to be at the machine to work with the data. Now, what crucibles to use with the machine? We have three options available. So we work with the classical alumina ceramic crucible, or we can work with platinum liner that are introduced in the crucible, so 10 grams of platinum gold alloy, or we can work with a full platinum crucible. Of course, the reason is because the ceramic crucibles, they are perfect for the analysis, but with time, they can become a little bit porous. You can still use it, but it's difficult to clean. And if you want to reuse the powder after for XRF analysis, for example, of course, ceramic is not adapted because you will have cross-contamination. So now let's start with some application and the case of bauxite. So the process to deal with bauxite in the laboratory, and the laboratory is first drying the ore, weighing, crushing, then subsampling, so dividing, and after the grinding. And to determine the composition of bauxite, we typically use a combination of XRF and TGA, or loss of ignition. So again, like explained, this is determination of LOI is complementary to the determination of element or oxide composition. So by XRF, we are able to analyze the major oxide. And if we add the LOI, we usually exceed 95% of the bauxite contents. Also, the TGA loss could be made at different temperature to assist in the confirmation of the mineral phases. And these have a high importance to know at which temperature we will do the refining, depending of the phase we have. Sometimes you need to have more temperature, and of course, it has an effect on the cost of process. So the condition for the thermogravimetric analyzer, so we'll use alumina-based ceramics. We work with 1 gram, grinded below 100 milligram, and we start with the non-dried sample. So the cycle, the analysis time will last about 2 hours and a half. And the first stage is made for the moisture determination at 105 degrees. And for that, we have a heating rate of 15 degrees per minute. And we will check the mass constancy 3 times. And we need to have a constant mass in the range of plus minus 2.5 milligram. And then after, we do the LOI stage at 1000 degrees. And we can a little bit speed the heating ramp. And after the same termination to reach the constant mass. So we check 3 weighing to see that we are still in the range of plus minus 2.5 milligram. And for the calculation, of course, we are calculate the loss of ignition as dry mode, so meaning the weight after we have dried the sample. So here we have an application with certified bauxite. So the BX 17 and BX 18. So here we have the XRF analysis for the 2 standards. If when we do the loss of ignition analysis, like I told you, at 2 heating steps, so first the moisture and then after the LOI at 1000, we reach the LOI value for the 2 standards. And if we add it to the value, we nearly reach 100% of the bauxite. So you can really see that it's complementary to the XRF analysis. Now the case of iron ore, sorry. So again, the TGA is also used to evaluate the ore's quality and the composition. And of course, there is norm for that, who say that we need to do to determine the loss at 5 different temperature, and it corresponds to the loss of different decomposition of different part of the ores up to 1000 degree, where we have the last loss of ignition part. So we can see here the sequential step of heating. So again, we are working with reference material, the GOP 142. Here we have the result of the certificate, and so we have multiplied the analysis for a couple of crucibles, and we can see that we obtain an excellent repeatability, so very good precision, and the bias is very close. So we have really something really close to the reference, and this for all the temperatures. So that's of course really good, and also I prefer to say that we have available, sorry, a couple of standards with a certificate value for the LOI, and it's not often it's not so easy to find standards with the LOI value. So now, if we speak about XRF, what we require is a high throughput, so it must be fast. So the conditions are the same. So we will work with 1 gram, but now we start with the sample dried. So in a lot of sites, the sample is dried before crushing and grinding, etc. And we can, if the product is packed as quite quickly, we can proceed at the LOI analysis directly after, before drying it. So in this case, we will heat direct from room temperature up to 1000 with a ramp rate of 50 degrees per minute. And again, to determine the mass constancy, we will do repeated weighing with a mass range of plus minus 2.5 milligram. And so we can see that on this thermograph, we have a fast heating ramp, and we reach after less than an hour the mass constancy. So it's really good and very fast. And also what we can see, and again, the sample used was the reference job 142, and we can see by the results that we retrieve, even by going direct to the last step, the same loss of ignition. So the bias is really good. Now another application, the cement. So again, the analytical method used to report cement composition involves XRF analysis, so elemental concentration, loss of ignition, and also additional chemical tests where applicable, and surely for some elements like chlorine, fluorine, etc. But nevertheless, the loss of ignition is part of the wall to get 100% of the cement. So it's often in the cement industry to prepare the calibration curves for the raw mill, the clinker, and cement. We work with the ignited materials, and the reason are because we can work with a single calibration curve. We have a better consistent flux to sample ratio, and clearly using that, we have a better accuracy. So what is really important in the cement industry is to obtain a fast analysis, like for iron ore. So again, we work in the same condition, 1 or 2 grams below 100 gram. And again, we'll work with the dried sample to be able to fast the thermogravimetric analysis. So it's done according to the norm at 950 degrees, and we have a heating rate of 55 degrees per minute. Same condition for the mass constancy, and we can see again the heating is really fast. And here we have a mass constancy below an hour, even better. So that's really excellent. And the standard deviation is really good in this condition. Now, if we come back with the way we can present we can have the sample for the fusion. So we can start with the calcined or the incalcined sample, but there is a third option using the uncalcined sample. But in this case, the LOI is measured as part of the complete sample preparation process. And as you will see, it have a great advantage in the workflow and surely for the accuracy. So in that case, we will again load the crucible. In this case, we will use 18 crucible and one reference crucible. So the crucibles used are fully made in platinum gold. And so we'll start the process, do the thermogravimetric analyzer at 950 or other temperature up to 1100 degrees. Like I told you, it could be interesting to do the loss of mass at the fusion temperature. And then after, when the TGA process is complete, the weight are transferred to the XR weight, which use also a 18 position disk. And the XR weight will automatically calculate and adjust the flux to sample ratio. So the XR weight is an automatic machine to load flux. So the machine will add the exact flux quantity to each crucible to keep the same ratio for all the samples. And then after, we'll transfer the sample flux mixture directly to the XRFuse 6 for the automatic preparation of the fused beads ready for XRF analysis. The big advantage of this system is that we can use the same crucible for the TGA, for the XR weight, and for the XRFuse 6. So we have what we call the portability. And of course, between the XR weight and the fusion, we will probably mix directly in the crucibles using a vortex mixer, for example, the flux and the sample. That's an important step, of course. And of course, it works with the samples who are not caking. But in the case of Simon and iron ore, where we made the most tests, there is no problem at all. So the big advantage of this technique is the throughput and the efficiency. So high throughput because, of course, you can process large LOI batches. So 30 if you use the liners, or 18 if you use directly the platinum gold crucibles. And after process the 6 fused beads in the XR fuse, we save time because the LOI measurements are integrated in the workflow. And it means that we will weigh the sample only once, so not on the side, the TGA, and the other side for the fusion. And also, this is not needed to weigh exact same mass for all samples, so we can average our weighing because the XR weight will adapt the correct ratio. And so it's a gain of time. LOI is determined with the desiccator time, but that's another process, and it depends of your condition. We can save the time at the TGA by unloading at 300 degrees, but of course there is some safety I would say issue or conditions for this case. Also, we improve the data recording because we have a complete logging of the LOI value, the sample weight, the flux amount, the dilution ratio. And also we gain in accuracy because each fused glass disc is produced with a precise known LOI value. And of course, that's really, really good. And also the dilution is calculated automatically and eliminating the dependence of an operator consistency. Okay, so that's all for this webinar, and thank you for your attention. And of course, like Jacques told you, if you have question, this is now the moment. Thank you. I think there is no question. You confirm, Jackie?
I think so. Yeah.
So it was clear enough.
I think it was clear enough. Right. Well, thank you all for joining us for this webinar on XRF analysis and loss and ignition by TGA. We hope you found the session
Uh,
informative. There's a question. Okay. Yeah. Tatiana Kalinichenko, apologies for my mispronunciation, but thank you for your question. She's asking about GOI, gain on ignition.
Yes. So, of course, it is possible to do. So the gain of ignition are a little bit more complicated to deal, and you need to know about what is in your samples. You need to know a little bit your samples, and the possibility to do the loss of ignition or the analysis at different heating step allow to determine when we have the oxidation and when we have the loss, and then after we can calculate more precisely. But yeah, clearly you need to know the sample you have, the composition of your sample. You need to have a roof ID for sure.
Yeah, absolutely. All right. Any other questions? No. Well, special thanks to you, Frederick, for helping us connect the practical applications with the analytical principles. And to everyone that attended the webinar, if you have any follow-up questions or, of course, would like access to the presentation, we will be sending out the link, which will be available on our YouTube page. And yeah, keep an eye out for our upcoming webinars and resources from XRF Scientific. And until the next time, take care and have a great day.
Thank you. Bye bye.
Bye bye.